graph a line through a given point with a given slope.
Slope.
All right, slope.
Slope. Oh man, you made me learn slope.
So, at this point, we have not seen anything like this. However, we have seen some semblances of physical representations of slope when it's on a coordinate grid. Can somebody please share with me a way that we have physically shown slope on a coordinate grid? What method did we use? Raven, what do you think? Okay, so he's thinking about rise over run, and I definitely think that's where we're at. I want to think about how we physically showed it, though, on the coordinate grid itself. Raven?
You mean like when you develop
What the heck?
Yeah, they made a shape. What shape were they?
triangle?
Triangles. We called them slope triangles. So we use slope triangles to show the slope and how the slope went from one point to the next. So here I am told that I have some line. I know that that line has the point 2, 3 on it. So I know this is part of my line. And that that line has a slope of 1/2. Well, it obviously cannot be a line with only a single point. So we need to figure out how to get some other points on this line. How can I use the information that's given to me to maybe find another point on this line? I'll give everybody a second to think about that. How can I use this other information that's given to me to find another point on this line? Better yet, turn to your partner, take 10 seconds, ask your partner or tell your partner, how can I do this? How can I find another point on this line?
You go. This is what you did. You go. That's what you did. When you get five. Boots.
You can move over to and go up.
Okay, please check me 5, 4, 3, 2, and 1. I hear lots of good ideas around me. Let's see what Marbella has to say.
Ian McCarter said that it's like the slope tells you how many times you have to go up and how many times you have to go down.
Perfect. So what I hear Marbella saying is that the slope is the rise over the run. And so that tells us where we need to go. It's kind of like a roadmap. It's saying, hey, you're at your point. You need to rise 1 and run 2, and that's going to get you to the next point. And the slope is still a roadmap to the next point. So from there, it's telling me, hey, there's your roadmap. Rise another 1. Run another 2.
Oh, this is good.
Rise another 1. Run another 2. Now, this would suggest that there are only points, if we keep doing this, this seems to make us think that there are only points going in one direction.
One direction sucks.
Moving in only a single direction.
There you go.
Are there points in the other direction?
Direction.
Yes, but I don't get it. Our slope says 1/2. How could we use our slope to get to those points? Because they tell us to rise 1 and run 2. That's all positive. That would be all going in that direction. Ian? I'm sorry. I can't hear Ian. which means you can't hear Ian, and he could be saying something brilliant and important. Ian, go ahead.
It's simplified, it could also be negative. When it's negative, you go down one, then across this.
So what I'm hearing you say is that negative 1/2 would be the same as 1/2. Let's check that. One of these, this is definitely good date. This is definitely bad date. Yeah, so they're both negative. This would both make a good date. We simplified yesterday slopes that were negative over negative to positive slopes like this one. So we can write this slope, we can write any slope two different ways. It's all about switching the negatives both top and bottom. So to get from this slope to this slope, I switch negative to positive and negative to positive. So now I can use this as my roadmap to go the other direction. That tells me to rise -1 and run -2. It tells me to rise -1 and run -2. What are the numbers in the parentheses? What do those stand for? What are the numbers in parentheses? What are the numbers in parentheses? Leslie. Yeah, that's a coordinate pair. That's a point. It's not a direction. Saying this is a point. Has nothing to do with telling us where things are going. It's saying this is a location. Just like I could say Jadea's house. That is a location. Slope is more of a direction, like 4 blocks east, 2 blocks north. Okay? Slope is a direction. These coordinate pairs are locations, not directions. Kyrie, question?
Would you get the same thing if you erased all those, started with 1 and then went up 1 and left 2? Would you get the same thing?
Up 1 and left 2. So left would be a... So what I'm hearing you saying is up 1, that's a rise of +1, and left 2, that's backwards 2. Is that the same? No. Okay. Jalen, do you have a question?
Yes. So basically, you just flip the negative, the positive 1/2 to negative.
Be very clear. This is not a -1/2. This is a negative over a negative. This is a good date. So we change good date form number 1 to good date form number 2. All right. Let's flip over and look at a couple more examples. All right. For this one, I have the slope -3/4 and the point 0.03. So that 0.3, that's our location. That's Jadea's house. Jadea's house is here.
I know where you live now.
And the slope, those are our directions. It's telling you rise over run. So to get away from Jadea's house, we want to rise down 3 and run +4. We could continue along the same line by going rise of -3, run of 4. Now, again, this makes us think that there are points in only one direction.
Stop! Not even funny.
There are points.
Horrible. Why is that funny? Stupid.
So this makes it look like there are points in only a single direction. How can I figure out how to get those points going in the opposite direction? Jadea and Kyrie cannot be the only people using critical thinking skills today. How can I get those points moving in the opposite direction? Emmanuel.
Go up 3.
So he's saying go up 3. That would be a rise of 3. And what'd you say? About the 4?
Up 4.
Left 4. That would be backwards, negative 4. Now, what we see here is, are these slopes the same? Yeah, they're both bad dates. These are the two different bad date forms of negative 3/4. So what you can see, to switch between forms, we switch the negative to a positive and the positive to a negative. So if you want to switch between forms of writing the slope, you can do that by changing both the top and bottom signs. Simple as that. So I'm going to rise 3 and back 4 based on the second way we wrote our slope. Second way I wrote our slope, back 3, or rise 3, back 4. So part of your work for today is you're going to show every slope written 2 different ways. Let's move on to the next one. Next one says that we have the starting point, the location, negative 2, 3. So we're going to find the location, negative 2, 3, and we're going to say that's where we're starting.
That's where we started.
Now here, the slope is 2.
I know, 2 and 2.
But wait, that's not a rise over a run.
2 over 1.
Iron?
And right 1.
But what about just go up 2, all right? So up 2, up 2, up 2. This would suggest that the slope was undefined. But this says the slope is 2, so it's clearly not, this clearly could not be correct. Esteban, what do you think? Add a 1. So he's saying turn this whole number into a fraction, so now it has a rise
Over.
and a run. Before I start following these directions, what's the other way we could write this slope? How else can we write a positive 2 over 1? Raven? Negative 2 over negative 1. This is the other good date form of the slope. So we can follow either one. I could rise 2, run 1. Rise 2, run 1.
Still 1, right?
Or I could go down 2 and backward 1.
2 backward 1.
Down 2, backward 1.
Down 2 backward 1.
Either way,
It's still
we're all getting points along the same line.
line.
You did a really good job that time.
I'm so
That line is straight and right through those points. Question from Kyrie.
When I did it, it's not. When I did the negative 2, negative 1, it's not. It isn't.
Did you go down 2 and backward 1?
Oh no, I went over 2.
All right. Coming down here to the bottom. I have a slope of negative 3 and a point 20. Obviously, the point 20, we can graph that. In people's work this morning, the most common mistake when they missed a problem had to do with graphing that first point in the wrong place. You have to be really careful. Anytime you see a 0 and a point, that's a trouble spot for many of you. So really think about what that means. This says over 2, up 0. Did I graph my point in the right place?
No. No.
No, I did not. That is a trouble spot for many of you. This says over 2 and up 0 to get to that point. This is the correct location for the point 20. Now, the slope gives us our directions. However, this slope only seems to be giving me one direction right now. It's only giving me a rise. That's kind of weird. Slope is rise over run. Slope only seems to be giving me negative 3 as the rise. Gerson, how do I fix this problem? It's already negative.
Oh, then it's a positive.
So you're going to tell me that this is going to fix my problem. That's going to help me figure out my rise and my run. Rogelio. Yeah, we need to add a 1. We may need to make this whole number a fraction. So this tells me that my rise is -3 and my run is +1. Now, what's the other way that I could write this slope? -3 over 1. Judea. +3 over +1. This one is a bad date. This one is a good date. Something's wrong. Alvaro. +3 over -1. This is a bad date. This needs to be a bad date. All right, so using the original directions, that's a rise of -3 and a run of 1. A rise of -3 and a run of 1. Using our backwards directions, that's a rise of +3 and a run of -1. Rise of -3, or rise of +3, run of -1.
What? He's distracting me. I'm doing the word. What are you doing? Nothing. I did my word. What? Oh, it goes up too?
All right, last one. I have the point -2, -2. Starting point here is -2, -2. My slope is rise of 3, run of 2. And what's the other way I can write this slope? I have a good date slope. What's the other way I can write this good date slope? Sage? -3 over -2. So we can follow either of those directions that we really want to. Rise 3, run 2. Rise 3, run 2. Or rise -3, run -2. Rise -3, run -2. Either is accurate. Either is fine. All right, key points, please. Kevin. Let's go ahead and make this part 1 of key point 1, number 1. So the first thing, first, graph the point. And in parentheses, we're going to say in the right place. Obviously, that makes sense. Then what? Kyrie.
Change this slope to a good date.
So you're suggesting that we need to...
Oh wait, do you mean like the next?
Yeah, what's the next step? So we have to graph the point, then what do we do?
You need to be a camera on her.
So all we got to do to get this work done is graph the point in the right place. We're done. All right, graph the point. Whoop, done. Well, somebody needs to finish this key point. Perla?
Carson, focus. Gosh.
Follow. Slope. Rise. Over. Run. To next point. Good. Key point number 1 is a list of steps how to go about doing this problem. That is a terrible spelling of the word repeat. Repeat. Following the slope. Key point number 2. Kyrie.
Calm down.
Change the slope.
If the slope is a whole number, make it a fraction.
Fraction. Whoop, whoop, whoop. What's it?
By putting a 1 underneath it. Or putting a 1 in the denominator.
Girl. Tayo.